Good afternoon dear students, this is Komal Yadav from upright classes and today we are going to start our next topic, that is trigonometric ratio of complementary angles. Okay, see, let us assume a right angle triangle OMP which is right angle at M and angle O is equal to theta degree. If angle O is theta, then what will be your angle OPM? Angle OPM will be 90 minus theta. Why it will be 90 minus theta? Since you know that the sum of all the sum of angles of a triangle is 180 degree and this is 90 degree and this is theta. So the sum of angles, these two angles will be also 90 degree and this is theta, so this will be 90 minus theta. Okay, now as you all know that sine this trick Pandit Badri Prasad Har Har Bore, in this trick perpendicular upon hypotenuse is the trick to remember sine theta. Sine theta is equal to perpendicular upon hypotenuse. If you assume this angle theta, okay, for this angle theta, what will be your perpendicular? We know that perpendicular is the angle, it is the line just opposite to the angle. This is the angle, so which is the line opposite to this angle? This y. PM is the line segment and this length is y. Okay, so perpendicular will be y for angle theta and base will be x for angle theta and hypotenuse will be line segment r. Okay, sine theta will be equal to y upon r since perpendicular is y and hypotenuse is r. Cos theta is equal to base upon hypotenuse. Okay, base is x and hypotenuse is r. In the same way, tan theta is equal to perpendicular upon base, which is perpendicular is y and base is x. In the same way, cosec theta is just reciprocal of sine theta, which is equal to r upon y, and sec theta is just reciprocal of cos theta, which is equal to 1 upon cos theta, and you can write it as r upon x. Same way, cot theta is reciprocal of tan theta, you can write it as 1 upon tan theta or x upon y. Okay, sine 90 minus theta is equal to perpendicular upon hypotenuse. If you assume this as your angle, this is your angle, so we know that perpendicular is just opposite to the angle. Okay, इस एंगल के अपोजिट आपका जो भी होगा वो आपका परपेंडिकुलर होगा. सो x is the line segment, OM is the line segment and it measures x. So this is a perpendicular and base is y. Perpendicular upon hypotenuse, so x upon r. Cos 90 minus theta, we have it that base upon hypotenuse from this trick, so this is equal to y upon r. Tan 90 minus theta is equal to perpendicular upon base, which is equal to x upon y. In the same way, cosec 90 minus theta is just reciprocal of sin 90 minus theta, which is equal to 1 upon sin 90 minus theta, which is equal to r upon x. Similarly, sec 90 minus theta is just reciprocal of cos 90 minus theta, which is equal to 1 upon cos 90 minus theta and is equal to r upon y. Same way, cot 90 minus theta is equal to just reciprocal of tan 90 minus theta and is equal to 1 upon tan 90 minus theta, which is equal to y upon x. Okay, so now we come to this conclusion that sin 90 minus theta, which is equal to x upon r. So you can write it as cos theta. Yes, obviously you can write it as cos theta because they have same values, x upon r or x upon r. Similarly, you can write cos 90 minus theta y upon r, which is equal to sin theta. Okay, similarly you can write tan 90 minus theta as cot theta because they both have the value x upon y and x upon y, and cosec 90 minus theta as sec theta. See, r upon x and r upon x, sec theta, and sec 90 minus theta as cosec theta. and this is equal to cot 90 minus theta. Cot 90 minus theta as tan theta, y upon x and y upon x. Okay, now let us take an example. First of all, remind these identities so that which will be useful to solve other few questions. Okay, without using trigonometric table, just solve this. Evaluate this question. If cos 53 and sin 37. Okay, how will you evaluate this question? You can write cos 53 as 90 minus 37. Yes, of course you can write it as 90 minus 37 and keep sin 37 degree as 37 degree. You already know from this identity that cos 90 minus theta is equal to cos theta. Okay, where here in this question theta is 37 degree. So cos 90 minus 37 will be equal to cos 37. Sorry, sin 90 minus 37 will be equal to cos 37. Cos 90 minus 37 will be equal to sin 37. Sin 37. Okay, sin 37 will be cancelled out, which is equal to 1. Let us take one more example. Cos 48 degree minus sin 42 degree. Cos 48 degree minus sin 42 degree. You need to solve this question. You can write cos 48 degree as cos 90 minus 42 degree and minus sin 42 degree. Okay, is there any problem? I don't think there would be any problem. You can easily write 48 degree as 90 minus 42 degree, and from this formula cos 90 minus theta is equal to sin theta. Here theta is equal to 42 degree, so you can write it as this whole as sin theta. Okay, that is sin 42 degree minus sin 42 degree. Both will be cancelled out. It is equal to 0. Okay, now let us take one more example. You need to find the value of this. Sorry, you need to verify it as 1. Verify it. How will you verify? Sin. How can you write sin 43 degree? How can you write sin 43 degree? You can write it as 90 minus 47. Yes, of course you can write it as 90 minus 47, and this is equal to cos 47. Okay. And this is cos 43 degree. Okay, so change the value of 43. You already know that you are taking theta as 47, so try to make all the thetas as 47 only. Don't change this one. If you change this one, you cannot, you will be unable to prove it as your question. Okay, cos 90 minus 47, and this is sin 47. You can write sin 90 minus 47, that is sin 90 minus theta is equal to cos theta, where theta is 47. So this is cos 47 plus cos 90 minus theta as sin theta, that is sin 47, or into sine 47. Okay, this is cos square 47 plus sine square 47. In the next chapter or next topic you will be reading that sine square theta plus cos square theta is equal to 1. Okay, so here theta is equal to 47 degree. Okay, so this is also equal to 1, hence which is equal to RHS.